Great day, students, and welcome back to day 5 of Labmas. And ladies and gentlemen, you have done an excellent job all week, but we are not done. Today, for our Labmas celebration, we're going... Whoa. 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 Okay. Okay, we're going to be studying wind, air, and how air can move things. In fact, we're going to be doing a lab today that focuses just on that. Focuses on how air can move pretty much anything. So, ladies and gentlemen, I'm going to get into a shelter so I'm not dealing with all this wind, and I'll be right back. All right, I think I am safe from the wind. Now, ladies and gentlemen, to learn a little bit more about wind, let's go to a vocabulary video so that we can learn just a little bit more about air and about wind.
Wind can move a boat, wind can start a storm, change the surface of the planet. You can understand it. Wind can be a breeze, wind can knock down trees. It can even help us make electricity. Wind can move a boat, wind can start a storm, change the surface of the planet. You can understand it. Wind can be a breeze, wind can knock down trees. It can even help us make electricity.
Wind can be described by its speed and direction. We have names for a few different types. Light wind is a breeze, strong wind is a gust. But what is wind and where does it come from? It can't be seen, but it's all around us. That's right, air. Wind is moving air. When air gets warm, it's less dense, which makes it rise. Leaving space for low pressure, cool, dense air rushing in, filling the space where the low pressure lives. The air rushing in is what we call the wind. The air rushing in is what we call the wind. And in time, the warm air cools down and sinks back down to the earth, which keeps the air moving around and the wind blowing too. Sometimes the wind even makes the trees groove.
Wind can move a boat, wind can start a storm, change the surface of the planet. You can understand it. Wind can be a breeze, wind can knock down trees. It can even help us make electricity.
Now, as you saw, wind is created by a change in temperatures. Some winds can be strong, some can be a gentle breeze, and sometimes there's no wind at all. Now, we know that wind can move a lot of things, and sometimes wind can even be dangerous. So what we want to do today in our lab is investigate a little bit on air and wind and see how we can kind of control the air and the wind. Now, one of my favorite cartoons ever, one of my favorite book series ever, is The Last Airbender. I've even modeled my haircut after Aang. Yeah, no jokes, no jokes. Okay, so in The Last Airbender, he is able to not just move all the other elements, but he's able to move air. And it got me thinking, can we create a science device other than the normal fan to move air and have air move other things? So, the title of our lab today is Becoming an Airbender. So let's go to the lab. Ladies and gentlemen, welcome back to the lab. Something's not right here. If you're anything like me, ladies and gentlemen, you may have a room in your house, whether it be the garage or spare room, that is just filled with boxes. I have a problem with throwing away and recycling boxes, and well, now my lab is all cluttered. I know, I gotta make them disappear, but I wanna find a use for them too. I don't just wanna throw them away. I got it. Today's lab. Today's experiment, Becoming an Airbender, we're gonna focus on using these boxes to create some sort of device to move air. Now, today's experiment is super easy, but before I do anything, I have to kind of, well, there. I didn't use air to move those, I just used me to move those. Now, what we're gonna do today is use these boxes and maybe three other materials to create a device that, well, is able to project air. Now, another name for this activity is called the vortex cannon. What a cool name, the vortex cannon. So, for today's Labmas experiment, ladies and gentlemen, I am going to show you how to make a vortex cannon and how to use it. The first thing we're going to need is a box. Now, where would I find a box? Oh yeah, I just threw a couple. So I'm just going to get one. Boop, right here. So all you need is a box. You need, well, it wouldn't be a science experiment without some duct tape. And you're gonna need a pair of scissors and parental supervision because this next part, kind of tough. So the first thing that I'm going to do is I'm gonna take my box, and I have a little cylinder here and a crayon, and I am going to trace a circle on one of the sides of the box, just like that. Now, if you notice, boxes have a length and they have a height, and we're gonna focus on the width right here. You wanna do it on this side, and you'll see why when we do it, all right? And the next thing you're gonna do, you're gonna need parent supervision to cut out the circles. So, well, my parents aren't here. I'm just gonna use the power of science, and there we go. And now you see, there's a hole in my box. All right, so what we're gonna do now is we're gonna seal up the box. So we close it, we get our tape box. Now, the goal is to have the box as airtight as possible. The only place that we want air to be able to come out is right here, and that's it. Now, I've known some people to decorate their boxes and make it look real nice. You can do that, and that's one of the cool things about this. It's a blank slate, isn't it? So you can put anything you want on here. Now, one thing I'm gonna do is I'm gonna seal the bottom just with a little piece of tape, just to make sure it's gonna be airtight. Now, we have our vortex cannon. Fairly easy, isn't it? Well, now we have to test it, but how are we gonna test it? How are we gonna get the air out of our vortex cannon? Well, this is the fun part. All you have to do is push down. When you push down, it squeezes the air out. Now, since it's circular, it is gonna come out in a wave, in rings, and come out straight ahead. Well, if you don't believe me, let's go ahead and test it. So for my first test, I have 2 balloons set up, and right now they are perfectly still. I want them to move. So I'm gonna take my vortex cannon and push it down, and let's see if we can send a vortex of air to knock over the balloons. Ready? Test 1. Test 2. Did you see it? We were able to, you probably didn't see the air, did you? But we were able to send out rings of air to knock down those balloons from, well, about 3 feet. I wonder how far away we could be to knock these down. Well, let's test the range, or how far away we can be with our vortex cannon. All right, so I'm gonna be about 5 feet away to start off with, and then we're gonna keep moving back. So here we go. Test 1. Test 1. Test 2. Test 2. There we go. So if you notice, it took a couple times to aim the further away we were. I wonder if we can go back even further. Now I am 10 feet away. Let's test the strength of the vortex cannon. Here we go. There you go, you see? We got up to 10 feet. for our vortex cannon, and it was still able to knock down the balloon. So, ladies and gentlemen, did we accomplish our goal of becoming an airbender? The answer is, of course we did, because it is Labmas, and, well, we accomplished our goals. Now, I'd love for you to make one of these at home and test it out. See how you can improve the design. See how you can make it look a little bit nicer. And see how you can even test the range of your own airbending machine called the Vortex Cannon. I'd love to see how you reuse these old boxes. Now, ladies and gentlemen, I want to thank you for another great Labmas day. We got the weekend, so we're going to take 2 days off of Labmas, but we will be back on Monday with another incredible experiment. So I hope you have a great weekend, and I can't wait to see each and every one of you on Monday.